This set of notes is on section 2.5, which is basically on vertical angles, proving angles that are congruent. We're going to focus on vertical angles. One thing we haven't talked about yet is what's a theorem. A theorem works the same as a postulate. It just has to be proven true before it can be used. My definition skipped over. So the word proven should be over here, a statement that has been proven to be true. Sorry about that. And let's see here, maybe I can, there we go, that should be right there. And we're also going to talk about a paragraph proof briefly. That's a proof that is not written in 2 columns, but written in complete sentences. The first definition you're going to need to know for today is what are vertical angles. And vertical angles are angles whose sides form opposite rays. Basically, anytime you see an X, you've got vertical angles. The top and the bottom would be considered a pair of vertical angles, and the left and right pair would be considered a pair of vertical angles. They are formed because 2 sets of rays go in opposite directions. So the reason we needed to start talking about theorems is because our very first theorem is about vertical angles. Theorems usually start as a postulate, or remember, postulates don't have to be proven true. Everybody just accepts them as true. And then somebody says, well, what about this? Or what about this? And then they take it a little bit further, and then other people are like, no, I don't know if that's true. That better be proven. So then it becomes a theorem once it's proven. So our first theorem, vertical angle theorem, simply says vertical angles are congruent. And so that means that the top and bottom angles in an X will always be equal, and the left and right values of an X will always be equal. So if we're looking at just this example problem, it says here that the measure of angle 1 is 106, and it asks you to find the rest of the angles. Well, based on the vertical angle theorem, we would know that angle 4 is 106, but how are we then going to find angles 2 and 3? And the easiest way to do that is to look at the relationship between the 2 angles that sit next to each other, either 1 and 2, or 1 and 3, or 3 and 4, or 2 and 4. Those form a straight line, and so we know that 2 angles that form a straight line have to add up to 180 degrees. So if angle 1 is 106, that leaves angle 3 to be 74, so that together they add up to 180 and make that straight line. But we also know from the vertical angle theorem that angle 2 and 3 have to be the same measure, so 2 would also have to be 74. So 2 and 4 would be 74, or excuse me, 2 and 3 would be 74, and 1 and 4 would be 106. Another example problem, this one has a little more algebra in it. They tell you that angle 1 is 4x plus 18, and that angle 3 is 7x minus 12. So using the vertical angle theorem, saying that those 2 things are equal to each other, we could set up the algebra problem. We could say that 4x plus 18 equals 7x minus 12. And then we would minus our 4x's over here, so we'd have 3x's minus 12 equals 18, and then we would add our 12 over here, so it would be 30 equals 3x, divide by 3, x is 10. So our x value is 10, but they actually want you to find angle measures. So what do you do with that x value of 10? You plug it back in. So 4 times 10 is 40, plus 18 is 58. So angle 1 would be 58. And now the next question is, what's the measure of angle 2? Well, I know that 1 is 58. That makes 3 58, because they're vertical angles. And then that leaves 2 and 4. Remember that these form straight lines, so they add up to 180 degrees. So you're going to do 180, and you're going to take 180 minus the 58. And what is that going to give you? That's going to give you 122. So angles 2 and 4 then would be 122. We can use vertical angle theorem in proofs with postulate as reasons. Remember, we can use postulates, properties, definitions, given, simplify, and now we can add theorems to the list because now we have a theorem. So let's look at this proof. What are we trying to do? We're given that the measure of angle 1 is 2x plus 3. We're given that the measure of angle 2 is 4x minus 101. And we're trying to prove that the measure of angle 1 is 107. All right, so step number 1, let's put our given information. I'm not going to write all that out. It'll take too long. So I'll just freehand it here, but on yours, make sure that you write it all in. Okay, so equals, blah, 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 blah. And that's given. Okay, so write this stuff down there. All right, so measure of angle 1 is 2x plus 3 and 4x minus 101. What's the relationship between angles 1 and 2? We know that they're vertical angles. So I know that the measure of angle 1 equals the measure of angle 2. And that's because the vertical angle theorem. I'm abbreviating because we're going to try and get this done. Okay, so vertical angle theorem. I'm okay if you just want to write vertical VAT as a vertical angle theorem. That works just fine for me. All right, so, but we have things that those are equal to, so we are going to substitute. We're going to, instead of putting in angle 1, we're going to put 2x plus 3. And instead of angle 2, we're going to put in 4x minus 101. What that substitution allows us to do is it takes the geometry out of it and puts the algebra back in so that we can work with our numbers and our values and not have to work with the actual angles themselves. Okay, so I'm going to minus my 2x. So I'm going to have 3 equals 3 equals 2x minus 101 because I subtracted 2x from both sides, so that's the subtraction property. Then I'm going to, I'm running out of room here, add my 101, so 2x equals 104, and that would be the addition property. I added 101 to both sides, and then I'm going to divide. So I'm going to divide by 2, and so x is 52 by the division property. Now, the trick is that angle 1 is 107, but I know that angle 1 was 2x plus 3, and that's what I'm trying to find. So if I stick 52 in here, that would be 52 times 2 would be 104, plus 3 would be 107. So my last step, I can write, now that I know that x is 52, I know that the measure of angle 1 is 107. And what did I do? I plugged the 52 in for x, which means I substituted. I substituted the 52 in for x. And I did simplify because then I put the like terms together. So you could add that in if you wanted to, but really just using substitution is plenty. Okay? So that's how you do a proof using the vertical angle theorem. You use it to say that two angles are equal. The last thing that we're going to talk about is a paragraph proof. A paragraph proof is basically where you write the proof, but you write it as a sentence instead of as a statement and a reason in two different columns. Okay, so this one is that it's given that 1 and 2 are supplementary and 2 and 3 are supplementary. So this, and you're trying to prove that 1 equals 3. So the concept still applies. You start with your given information, and when you get down to what you were trying to prove, you're done. But you write things like, it is given that, and then that would be your hint then that measure of angle, so we would say 1 and 2 are supplementary, and 3 and 2 are supplementary. Okay, so that would be a statement that's your statement and your reason right there in the sentence. Then you go on to the next piece. Okay, so then you know that. So that tells you that you're going to your next statement and reason. Okay, what do we know? That if 1 and 2 are supplementary and 2 and 3 are supplementary, then we know that angle 1 plus angle 2 equals 180. And we know that angle 2 plus angle 3 equals 180. That's because of the definition of supplementary. Okay, so again, we have a statement and a reason in our sentence. It's just written together instead of in the 2 columns. Okay. Then we go to the next one. Then you can, and I give you the hints here, then you can use substitution. Since they're both equal to 180, they have to be equal to each other. So we would say that angle 1 plus angle 2 has to be equal, and we should probably be using congruent here because we're talking about the actual angles, equals angle 2 plus angle 3. We would say that those are congruent. And then it says that you can subtract. Well, subtract says you have to take the same thing from both sides. Well, there's an angle 2 on both sides. So we will subtract angle 2 from each side, and then you get that angle 1 would be congruent to angle 3, and that's what needed to be proven. So that's how paragraph proofs work. They basically work the same way as 2-column proofs. The only difference is that you write them as a sentence instead of in 2 columns. All right, that concludes this lesson, and there's your homework for each class.